Hi and welcome to this screencast. Today I'm going to talk about how you can use indexing to extract elements from a vector, how you can extract a single element, multiple elements, and how you can use logical indexing. And I'm also going to tell you about how you can use indexing to modify elements in a vector. Now first let me create a vector. I'll call it x, and I'll put in some numbers like this. And we can see the vector appears up here. Now if I want to extract the third element, that's the number here, 2.3, I can simply index using square brackets, and I'll take the index 2 because the index starts with 0, so 0, 1, 2, that's the third one, and that will give me the number 2.3. Now Python displays this as 2.29 because of numerical inaccuracies, but it's the correct one. Now I could also put in the index into a separate variable. I could call that index, for example. Index equals 2, and then I can type x of index, and that again will give me 2.3. If I want to extract more than one number, I can simply index with a vector. So I could type x of and then a vector, and in a vector I could put in, for example, 1, 3, and 5, and that would, I'll put in 0, 2, and 4 to get the elements the first, third, and fifth element from the vector x. So that should give me 1.1, 2.3, and 3.5. Again, of course, I can put that index into a separate variable. I could type index equals this array, and now I can simply type x of index to get the values I need. Now another thing you can do is to use a logical vector, a vector containing true or false, to index into a vector. And that logical vector has to have the same length as the vector x, and for each value in the x vector it has to be true or false, and if it's true, that index will be extracted, and if it's false, it will not be extracted. So I can simply type x and then index with a vector, and now I'll put true, false, true, false, true, false, 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 like this. That should extract number 1, not number 2, number 3, not number 4, number 5, not number 6, 7, or 8. And it returns, as you see, the same result as before, number 1, 3, and 5. And again, I can put that into a separate index variable if I want to, like this. So I create a logical vector, we can see it up here, with these true or false values, and I can simply type x of index to get the first, third, and fifth value from x. Now the techniques that we use to index and extract elements from a vector can also be used to modify selected elements inside the vector. So let me show that. First I'll create a copy of my vector x, and I'll call the copy y. Now for example, if I want to access the third element in y, I can write y of 2. Remember to start the indexing by 0. So I can use this expression on the left side of an assignment operation. So I can say y of 2 is set equal to, for example, 77. And now we can see that the third element in y is changed to 77. Now let me reset my y vector. Using the indexing operations as before, I can also change multiple elements at the same time. So I can use a vector to index into y, and let me, for example, use a vector to get the first, the first, the third, and the fifth elements of y. Now if I want to set them all equal to 77, I can just write it like this, and now we can see that the first, the third, and the fifth element of y are set equal to 77. Let me reset y again. I can also use a vector on the right side of the assignment to set the multiple elements to different values. So I can simply write y of np array 0, 2, and 4, so the first, third, and fifth element, and I set that equal to a vector, for example containing the values 20, 40, and 60. So now we can see the first one is set to 20, the third is set to 40, and the fifth one is set to 60. Let me reset y again. Now, as you probably know, we can use logical operations to test values of y. For example, we can test values of y that are greater than 5. So if I write y greater than 5, I would get a logical array the same length as y, where all the values that are greater than 5 will get a true, and all the ones that are less than or equal will get a false. And as you know, these types of logical vectors can be used to index into y. So if I want to extract all the values from y which are greater than 5, I can simply use an indexing operator, say y of y greater than 5, and that will return all the values in y that are greater than 5. I can also use this on the left side on an assignment, so I can say y of y greater than 5, that's all the values in y that are greater than 5 are now set equal to 77, for example. And when I run this code, I can see that all the values of y corresponding to values that used to be greater than 5 are now set to a different value, 77. Logical indexing is a very powerful method that it's quite important to master. But sometimes it can be a little bit confusing with these logical vectors. For example, if I type x is greater than 5, I will get this logical vector that indicates which values of x are greater than 5. But sometimes it can be nicer to have a simple vector of indices of the values that are greater than 5. And that's quite easy to do using the np.where function. So I can type np.where x is greater than 5. That will convert this logical vector into a normal vector of indices.